Have you ever wondered what would happen if a bomb went off nearby? It's a pretty terrifying thought, right? But it's one a lot of us have had. Today, we're going to get right into it and explore the anatomy of an explosion. We're talking a journey from the simplest, most basic devices all the way up to weapons that are powerful enough to literally circle the globe.
But beyond all the tech and the science, there's a much more fundamental question, isn't there? Could you survive? That's what we're going to frame this all around. We're going to break down how these things actually work, what they do to a person, and what survival even looks like as the danger gets bigger and bigger.
So yeah, let's just dive right in. What we're about to see is how humanity got really, really good at the science of destruction. It's an incredible and honestly pretty scary story of escalation, from something that creates chaos on a street corner to something that can wipe a city off the map in the blink of an eye. Okay, so every story has to start somewhere. And for explosive weapons, it all begins with the absolute basics: fire and little bits of flying metal. We're talking about the foundational stuff. Weapons that are up close, personal, and just brutal in how simple they are.
And right away, you see this huge difference between pure chaos and careful design. On one hand, you've got the Molotov cocktail. It's a totally improvised weapon, right? It doesn't really explode in the traditional sense. It just spreads this sticky, burning fire everywhere. But then you have the fragmentation grenade. Now that is engineered for one reason and one reason only: to blast out a storm of metal shards at over 1,000 kilometers an hour. Two very different approaches to destruction.
So survival at this stage, it really comes down to one thing: distance. Get more than 2 meters from a Molotov and you might escape the worst of it, but you're still looking at serious burns. For a grenade, you need more like 10 meters to be out of the immediate lethal zone, but you're still going to get hit with shrapnel. And then you scale up to something like a World War II aerial bomb. Even at 150 meters away, the world around you becomes the weapon. Glass from windows turns into daggers, and entire buildings just fall apart.
All right, so after fire and shrapnel, things get creative, and I mean disturbingly creative. This is where we see how chemistry was weaponized to create these uniquely terrifying effects, all before anyone even thought about splitting an atom.
This isn't just fire. This is fire that sticks to you. Napalm, which became infamous in Vietnam, is this gel that burns at insanely high temperatures. And the scary part? You can't just put it out. Water doesn't work. It just keeps burning. It's a weapon designed to be inescapable.
And then there's this thing. A thermobaric bomb, sometimes called a vacuum bomb, introduces a whole new level of horror. It kills in 2 stages. First, it sprays out this fine mist of fuel, creating a cloud. Then, it ignites that entire cloud at once. You get this massive shockwave, but the part that's truly brutal is what comes next. The explosion burns up all the oxygen in the air, creating a powerful vacuum that can literally rupture your lungs and your internal organs, just from the change in pressure. This quote just nails it, doesn't it? It perfectly captures what makes a thermobaric weapon so terrifying. The damage isn't always visible. A building might still be standing. A person might look untouched on the outside, but inside, everything is destroyed. It's a weapon that goes after your biology. And here we go. This is it. This is the moment the entire game changes. We are now officially entering the nuclear age. A time when a single weapon, a single device, holds the power to completely erase a city from existence in a flash of light. This is the science of fission.
So, how does this even work in simple terms? Well, you take a really heavy, unstable atom, and you split its very core, its nucleus. And when that split happens, it unleashes a colossal, almost unimaginable amount of energy. And that energy comes out in 3 main ways: a fireball that consumes everything, a blast wave that flattens anything left, and something new, something sinister: radiation. And the first 2 atomic bombs used in war really show this in action: Little Boy and Fat Man. They were both devastating, but they actually used different designs. Little Boy used uranium in a sort of simple gun-type trigger. Fat Man used plutonium in a much more complex implosion design, which actually made it more efficient and powerful. But you know what? For anyone within half a kilometer of ground zero, the design didn't matter. The result was exactly the same: instant vaporization. The only things left of them were their shadows, permanently burned into the stone.
But here's the thing about an atomic bomb. It doesn't just kill once. For the people who somehow survived the initial blast and the firestorm, a slow, invisible killer was waiting for them: radiation. It causes something called acute radiation syndrome, which is just a horrific way to die.
And even for those who seemed to recover, the damage was done. Cancers would show up years, sometimes decades later. An atomic bomb just keeps on killing, for generations. So, if splitting the atom was a huge leap forward in destructive power, this next step is like jumping into a whole other dimension. We're now talking about thermonuclear weapons. We're talking about harnessing the very same process that powers the sun itself, nuclear fusion.
Just look at this chart. It's almost impossible to wrap your head around the scale. The bomb dropped on Hiroshima was 15 kilotons. A modern B-83 hydrogen bomb is 1,200 kilotons. That's 80 times more powerful. And then you have the Tsar Bomba, the biggest bomb ever set off, 50,000 kilotons. We're not talking about destroying cities anymore. We're talking about destroying entire regions.
Okay, let's just try to process the Tsar Bomba for a second. 50 megatons. That is more than 3,000 times the power of the bomb that destroyed Hiroshima.
Its fireball, the initial fireball alone, was 8 kilometers wide. It punched a hole 64 kilometers high all the way up into the stratosphere.
But this is the most staggering fact of all. The shockwave from that one explosion was so powerful that it was measured circling the entire planet 3 times. A single man-made event sent a ripple across the whole world.
All right, after all of that, we have to take a step back from the pure science for a minute. We've seen the what and we've seen the how, but now we really need to look at the who and maybe even the why.
This timeline, it just lays out a really disturbing truth, doesn't it? In just a little over a century, we went from throwing fire in bottles to creating explosions that can literally change the planet's climate. Think about that. We developed more ways to destroy ourselves in the last 100 years than in all the thousands of years of human history that came before.
Ultimately, all these bombs, all this technology, it exists because of science. But science, at its core, is just a tool. And a tool can build a house, or it can demolish one. It can cure a disease, or it can become a weapon that brings about our end. The science isn't the problem. The problem is us.
And that leaves us with this final, really heavy question. History shows us pretty clearly that we're never going to be short on the technology for destruction. What we seem to lack, time and again, is the collective will to stop. So, as we keep innovating, as we keep discovering new things, the real question isn't what can we build, but what will we choose to build next?